Right, this video deals with what we call inverse functions. Okay, we start out, we say we can only get the inverse of a bijective function. Again, more about that later. I'll come back on that. The function has to be either injective, or sorry, it has to be injective and surjective. Again, more about that later. All right, so inverse functions. If we reverse the couples of a function, we get what's called an inverse function. Okay, so if f maps 1 onto 4, then the inverse function, we call it f minus 1, maps 4 onto 1. So it maps the output back onto the input. For every couple AB created, the inverse function will create the couple BA back to itself. Now, if you want to look at that graphically, it means that, let's say you had a function f of x here. Its inverse is simply the mirror image of the original through the line y is equal to x. Now, we're actually already familiar with inverse functions. We're familiar with the inverse sine function. So, for instance, if sine of 30 is 0.5, then the inverse sine of 0.5 is equal to 30. So, in other words, you get back to where you were at the start if you apply the inverse. You can also say that f after the inverse function will get you back to x. That makes sense. You go back to your original. Or in the opposite direction, if you do the inverse after f of x, you get back to x as well. The domain of f is the range of the inverse function. Now, we need to know how to find the inverse of a function. So our steps are, first of all, we get x in terms of y, and then we swap the x's and the y's. So here's an example. You have f of x is equal to 5x minus 3, and you have to find the inverse function. So all you do is you say y equals 5x minus 3. Swap it around. I'm going to say 5x is equal to y plus 3. We'll take it across and reverse them. And then x is equal to y plus 3 over 5. And all you do now is swap around and you say y is equal to x plus 3 over 5. And you're done. Hence show that the inverse function of the function is equal to x. Okay, so what we'll do now is we're going to say this is the inverse function, and we're going to say we know that f of x is equal to 5x minus 3, and then if we do the inverse function on that, you say, okay, so you go to your inverse function, and everywhere you see an x, you're going to put 5x minus 3. And then you put plus 3, and then it's over 5. They cancel. You get 5x over 5, and that's simply equal to x. And that's what we're supposed to show. Is there anything else there? No. Okay, the diagram on the right shows a reflection of this curve. This is a cubic in the line y is equal to x, which will give you, as we mentioned earlier, the inverse function. Find the equation of the inverse function. So again, what we're going to do is we're going to say y is equal to x cubed plus 1, and we're going to swap it around. We're going to say x cubed is equal to y minus 1, and then x will be equal to the cubed root of y minus 1. So that's your inverse function. Oh, sorry, excuse me, I just have to swap around the y's and the x's. Y is equal to the cubed root of x minus 1, and that's the answer. Okay, we also can get the inverse using completing the square method. Okay, so as I say, completing the square method, we're going to first complete the square on this. So you have y is equal to x squared minus 4x minus 4. Y is equal to x squared minus 4x. Now to complete the square, we add half the coefficient of x, which would be a 2 squared. Now we still have the minus 4, so we insert that. Now if we put in the 2 squared, we have to take it out again as well, just so the two lines will be equal. Now having inserted your plus 2 squared, you know then that that is equal to x, because there's a minus there, it was minus, put that number there, 2 squared, minus 4 minus 4. So you end up with x squared minus 2 to be squared, minus 8. Now we swap it around, we're going to say x squared minus 2 to be squared. Sorry, that shouldn't be an x squared, that's wrong. That's to be squared is equal to y plus 8. Now we get the square root of this side, x minus 2 is equal to, and we get the square root of this side, y plus 8, only get the positive square root. And then you're going to say x is equal to the square root of y plus 8 plus 2. Now again, the next step is to swap the y's with the x's. Square root of x plus 8 plus 2. Okay, so that's your inverse, your f minus 1. Now you have to write down the range of f to the f minus 1. And what we say is the range of f minus 1 of x is equal to the domain of f of x. So your answer there is your range of inverse x is equal to, now you go back up, see here the domain is x greater than 2, so you simply say y greater than 2, and that's it. Okay, so if you could do EDCO Sample D, Paper 1, Question 5, B only, and then if you do exercise 1.4 on page 22 of book 7, if you do questions 1, 3, 5, 7 and 12, and solutions will be up on Schoology. Thank you.